Okay, so we are looking over slides 45 through 48. Here is 45. So you can pause it to double check yours if you need to. Okay, so we are going to go on to slide 46. And I changed number 2 because it didn't really make sense with that without the gift card. So I put the total with a $25 gift card can be no more than $75. Okay, so let's look at the first one. Kayla rented a bicycle while she was on vacation. She paid a flat fee of $55 plus $8.50 each day. Total cost was $123. What was the number of days she rented the bicycle? So our variable could be D. I'm going to do lowercase d. D for days, and it changes it. There we go. D for days, number of days. So whenever you say what the variable is, make sure you not only put the letter, but also what that means or stands for. And then this is an equation. So I'm going to do a little circle around equation. And I have to change the fill color so it's transparent. Let's see.
Is it okay if I just wrote it out?
Yeah, that's fine. Okay, the next one we need to solve, so we need to write the equation. So 55 plus 850 per day equals 123. Okay, so then you should have worked that out. If we subtract 55, I'm just going to do it like this. Then we get 850D equals, whenever you subtract 55, what do we get there?
68.
68. And then we divide by 850. So then D equals 8. Okay. So I wrote that with words, and now all I have to do is go back and draw, or not with words, but with typing, do the little lines. You do not have to do that. You could have taken a picture. You could have written it out and taken a picture. Okay, so answer in words.
8 was the total amount of days I rented the bike.
Kayla rented the bike for a total of 8 days.
Can I leave mine how mine was? Is that okay?
You need to write it in words. Yeah, yours is right.
Yes, sir.
Yeah.
So
Okay, so the next one, Oscar needs to buy 4 work shirts, all costing the same amount. The total with a $25 gift card can be no more than $75. So we need to write what the the variable is. What do we want to use as our variable?
the cost of the work shirt.
Okay, so what letter? It doesn't really matter, huh? C. Cost per shirt. Cost for one shirt. Cost of a shirt. Okay. And we used X, I guess, Friday when we did this. All right, now we need to solve it. I'm going to change that to C minus 25. That's an equal to 75. I could do this in Equatio, and it would be much prettier.
Well, that takes more work.
So in order to solve it, we would do plus 25 to both sides. And we get 4C is less than equal to 100. Divide by 4. Divide by 4. So how much can each shirt cost?
25.
Shh. Because that's how I do my line whenever I actually write it down on paper. All right, so C is less than or equal to 25. So how can we write that in words? Each shirt should be no more than $25 a piece. $25 per shirt. She can spend, or he can spend up to $25 per shirt. That would be another way to write it. Okay, the next one. Juan has 11 more than twice as many customers as when he started selling newspapers. He now has 73 customers. How many did he start with? What would be our variable? Huh? C for number of customers. What did you say?
I said, you see.
You see?
Yeah,
Oh.
I said,
Her limit
you see,
40
I don't know.
calculus.
Really hard. Yeah, I said, you see, I don't know, but she just didn't see it. Okay.
All right. Is this an equation or an inequality? Equation. I'm going to change this to red. Okay, we need to set up the equation. So 11 more than twice as many customers as he first started with. So when we do twice as many and we have 11 more than, we actually have to do the twice as many customers plus 11. Or it could be vice versa. Equals 73. If we solve that out, I'm not going to worry about solving that out. Y'all know how to do that. What does C end up equaling? 31. Because y'all know how to do that. I'm not going to worry about formatting that because you've already done that, hopefully. Then we need to write the answer to the question. How many did he start with?
Number of customers he started with was
He started with 31 customers? Is that good? Okay. Next one, Katie's problem. Katie has $40 to spend at the state fair. Admission is $6 and each ride costs $3. What is the greatest number of rides she can go on? So what is our variable? R for number of rides. Is this an equation or inequality? The greatest number of rides she can go on. Inequality. Okay, so now we need to write the inequality. So R stands for number of rides. So we are doing, it says State Fair. She has $6 admission, and each ride is $3. So it should be 3 times R plus the $6 admission. We want to find the greatest number where she can only spend the $40. Less than or equal to 40? Okay. Insert that in. Then when we solve it out, you should subtract 6 on both sides, divide by 3. R would be less than or equal to, what did it come out as?
Rather to 11. Yeah.
Okay. So it's less than or equal to 11 1/3, right? Okay. But when we are writing this in words, we can't do 1/3 of a ride. So how can we write this? Okay. Katie can ride up to 11 rides. No more than 11 rides. 11 rides or less. Okay, and then we just have one more slide to do. Okay, so this is the last slide. So solve and graph the solution. So it says the sum of x and 3 is less than 8. So in this green, we are going to write the sum of x and 3, x plus 3 is less than 8, right? Then we solve it. So you move the 3 over, and you end up with x is less than 5. So we are putting the numbers on here. We're doing the interval notation, set builder notation. Okay, so here is showing you about set builder notation.
Welcome to lesson 28 in the intermediate algebra series. In this tutorial, I'm going to be explaining set builder notation. So here's a set that uses set builder notation. So basically we have this vertical line here, and then the information that's on the left-hand side of the vertical line is an arbitrary name for an element. So if you look at the right-hand side, this shows the conditions for an arbitrary element to be part of our set. So the right-hand side says that all of the elements that are greater than the value 2 are included in our set. So if we were to draw this on a number line, we put the number 0 here, the number 1, 2, 3, 4, and this just keeps on going off into positive infinity. Then the first step we would take is we would shade in all of the values that are greater than the value 2. And then we'll put a little arrow here to show that all the numbers that go on in that direction are also included in our set. And so now at the value 2, we need to make a decision. There's two choices. We can either put a half circle here or a square bracket. So one of these choices is right and one of these choices is wrong. So let me show you when you want to use each of these. So we use the half circle when we're dealing with a less than sign or if we're dealing with a greater than sign. We use the square bracket when we're dealing with the less than or equal to sign or the greater than or equal to sign. So in this case, we're just dealing with the greater than sign, so we use the half circle. So now looking at the graph here, this represents the set that contains all numbers greater than the number 2, but not including the number 2.
Okay, so this is very similar to the open and closed circle. We are going to continue to use open and closed circle, but later on in different math classes, you may see the parenthesis. This is kind of like a parenthesis, right? It looks like a parenthesis, and this looks like the bracket that we had been dealing with. But we're going to use open and closed circles. So on here, our set builder notation, let's put it over here, is do the little squiggly bracket, X, and then right above return on your keyboard, you can do the line. Can y'all see that? You do shift and then the little slash.
Wait.
What's it above?
Oh.
Enter. And then X is less than 5.
You said a lot of big words that I don't know.
I'm going to put a little space. There we go. I'll put a little bit more space in there. I'm going to make it a little bigger. So it's right above return is this line right here. So you may see your solution written out like that. It's a set. X, anything in these braces deals with a set of numbers. So we are talking about the set of numbers that we are representing as X, where X is less than 5. So now we can put our numbers here. So let's go to 0, 1, 2, 3, 4, 5, 6.
And okay, if our number line is different.
Yeah, your number line can be different. And since it's just less than, it's going to be an open circle on 5. And it is less than, so it is going left. There we go. Okay, was everybody able to do that? All right, let's go to the next one. The difference of B and 1/2 is at most 3/4. So let's see. The difference of B and 1/2. So the difference would be what operation? B minus 1/2 is at most 3/4. So what do we deal with when we're dealing with at most? Less than or equal to. And you can look back at that previous, I think it's slide 45. At most 3/4. But then we need to solve this. So how would we solve this?
Plus 1/2.
Yeah, plus 1/2 on both sides. So 3/4 plus 1/2, what would that be?
Could you find the common denominator between the two where they cancel out the fraction?
You could multiply by 4. But since we're only adding half, think about half as 0.5. 0.5 plus 0.75, right? If we convert them over to decimals. So then if you add those together, you get 1.25. Is that right? 1 1/4. Okay. Okay, so now we need to do the set builder notation. So it's a set, so it's the brace. B is our variable. The line means such that. So a set of B such that B is less than or equal to. I wonder if I can just grab this from the special characters. Is there a less than or equal to sign here? Y'all see where I got that? But that's the wrong one. I went to insert special characters and then I typed in less than. So less than or equal to 1.25 and then close the brace.
Insert.
Insert symbol special character, or you can use Equatio. Yeah, that's fine too.
How do I insert? Do I just click it?
Yep. And it should insert right there where you were typing. Okay, and then we need numbers. So let's do 1, 0. I'm gonna go, let's see. We want 1 1/4, right? So let's make this 1. Let's skip 2, 3. So basically every line is a half. And it's going to be or equal to, so that means I need to get the circle. Oh, it's 1 1/4, so it'd actually be between halfway between 1 and 1 1/2. I'll move that down a little bit. Does that look okay? Were y'all able to do that? Okay, good. Okay, the last one. 5 subtracted from M is more than 11. So if we use subtracted from, that's one of those phrases that switch the number and the variable around. So 5 is subtracted from M, so it means M minus 5 is more than, so what symbol do I use for that? Greater than negative 11. Make this a little bit bigger. So then we add 5 to both sides. So M is greater than what? Negative 6. Okay. So now we need the set builder notation, which includes the braces. And the set we're dealing with is the variable M. M such that M is greater than negative 6. don't need Equation anymore, so I'm going to close that. Okay, so let's think about our numbers where we want -6 kind of in the middle. I'm going to put -6 there first. And then going up, or I guess going down, it doesn't matter. That'd be -7, 8, 9, -5, -4, -3. There we go. And then, are we doing an open or closed circle? Open, so I'm going to grab one of these open ones down here. I mean, up there. Pull it down. Oh, we wanted to go the other way too, because it's going to be greater than -6. Okay, so that should have completed slides 45 through 48 now. Okay, if you need to, you can go back and rewatch the video. So your last slide that you'll need to do for Wednesday when this is due is your reflection. So this is reflecting over everything we were doing with equations and inequalities for the whole year so far. Okay, so you're not going to do that right now. You'll need to do that before you turn it in on Wednesday, and make sure everything is completed on every single slide. So go through these, and this can also help you study for your test. So let's look at your assignment for today. I'm gonna move this up top, maybe. There we go. You are, we are checking our answers on the slide, so we went over that. And then here's your assignment. It's a Google form. You're going to complete these problems. Let's see. 4 less than 2 times a number is 18. Find the number. You can put x equals the number, or you can just put the number. Okay?
The actual number type in the number.
You can actually put the number in. So if it counts it wrong, then we'll figure out how to make it right. But this is our first attempt at the Google form with putting in answers in here. So let's see how it goes. Work these out in your journal. That way, if I ask you to see your work, then you can show that to me.